Hi, everybody. So let's begin. So who am I? My name is Srdjan Vranac. I'm from Serbia, from a small city called Novi Sad. I am a business owner, developer, mercenary, whatever you want to call it, consultant. I'm writing terrible code that performs exceptionally. I'm wrangling elephants and pythons on a daily basis, and I'm obsessed with process automation. I'm interested in continuous integration and delivery, clean code, testing, best practices, and of course, distributed systems. Now, a word of warning. I'm partial to using images, as I do believe that they drive the message harder into your brain, and I also do not have a lot of code in my slides. As we are speaking about distributed systems, the speaker, me, may or may not exhibit race conditions with words, lagging thoughts, and occasional segfault or OOM. This is not a result of stage fright or poor preparedness. It is a carefully choreographed act that you should not try at home. So, welcome to the DDD talk. Not that kind of DDD. Today we are talking about distributed domain destruction. So, first question would be, what is a distributed system? The simple definition is that it is a system where you distribute processing of tasks to other workers. By tasks, I mean costly tasks. It can be anything ranging from heavy computation and CPU utilization to long-running processes. If we are talking in the context of web applications, basically anything that can't be done within a request is a good candidate for distribution and background processing. A more realistic definition is that a distributed system is one in which the failure of a computer that you didn't know even existed rendered your own computer unusable. So let's have a crash course. Imagine you just made a shiny new application that scrapes information from about products from different websites every 12 hours, right? It's a simple setup. You have, you get your HTML from URL, you look a few things in it, you update the database, you create a screenshot of the URL for the auditing purposes, a cron job will trigger the process, and everything works really well. As the number of products increase, your current setup becomes insufficient and underperformant for your needs. So now you need to switch to a distributed system by using tasks or message queues. Task or message queues. The distinction between and in and out between tasks and message queues is like a whole nother talk. But for now, we will focus what you can, should, and need to do with your setup to get to a distributed system. In essence, you will take an axe to your code and you will split things up, right? You will have one set of workers getting the HTML. You will have another set of workers that is parsing that HTML and update the database. And you will have another set of workers that is going to create a screenshot from the URL. You add some publishing scripts into the mix, that one that start the whole thing, and a message broker like RabbitMQ. And this is great because now when you split things up, you can actually scale as much as your client wallet allows, or heaven forbids, your wallet. Congratulations, you're now distributed. So you can scale, so you go to your clients and you lay out your plan. You want some 1,000 workers or so spread across 20 instances, so that will be some 50 worker processes per instance, meaning you can get cheaper machines, bring the cost down, and tie it all with message broker, and then you see it. You see that moment when you lost them. And the next part of the conversation goes something like this. So why don't we get just bigger instances that can use, say, 500 workers per instance? That way we have less hassle. It might be cheaper as we have less overhead. God damn it. There goes your plan. But it is not that bad yet. You still get to launch your distributed system and see where it goes from there. Now, In order for your distributed system to work, you need to keep your workers running, and they will exit because of timeout, because there are no jobs available, or some kind of exception. Your workers need to be kept running constantly. So we have to use daemons to keep an eye on them and start them in any number of instances that you need. Most popular one would be supervisor and upstart, which is basically canonical takes a supervisor that was integrated in Ubuntu and now is being replaced by systemd, which is like a whole different tragedy. Both are well documented, both are straightforward to use, and of course both are just waiting to bite you in the ass. Now, supervisor is older, it's more mature, it's easier to set up, batteries are included, works fine, until you need to run more than, say, like 350 workers at any given time, and in our case we need 500. When that what happens is that supervisor will try to run them all at the same time and keep crashing them until eventually everything stops responding. I mean, it's really beautiful. My guess is that it depends on the version of Python and how it was compiled and the number of limit that is set on file descriptors. Of course, as an alternative, you have upstart, which is using stanzas, which is a fancy name for commands and templates, and it is a bit more complicated to set up, but it can handle some 600 workers on an instance easy. It also has this concept of signals to control your workers so you can fine-grain with your needs. And this is where things start to get weird. If you have more than, say, 3 types of signals that upstart can detect, there is a chance that any of them will be ignored. So when you, for example, stop your workers, in reality they keep on chugging. Both edge cases have been reported on the respected issue trackers, and the last time I checked, there was no definitive fix. When working with daemons, sooner or later, you will look like this, unfortunately. So, on to something a bit more serious. Logging and counting. So, in a normal application, it is nice to have, right? Maybe it's important. It's one of the tools that will tell you what is going on. In distributed systems, logging is essential because that is about the only way to find out what went wrong, and maybe, just maybe, logs will show you how it went wrong. So, when I say log, I actually mean log and count. Not only by outputting the information from your application to the files and counting everything, and then you can graph it, and see, I told you. And then you can see how many counters at any given point have been incremented. And so all of a sudden, if any of those counter drops, you know that something is happening and you can take steps to fix it. So every time error happens, you can actually improve upon it. When you aggregate all of these data and put it in one place, suddenly you can see every action of your system. And you can have an idea what is happening. Because when you run something locally, it might take 5 seconds or 10 seconds, but you have no actual idea what it means. But when you deploy it to production, and then you need to know how long it takes, because how long is the queue, how many messages are them, how many workers are them, etc., etc., etc. The more metrics you collect, the fuller picture you have about the state of your system. A lot of those measurements involve collecting data on different kind of things: memory usage, I/O rates, CPU rates, network throughput, disk I/O, number of messages in queues, average time to consume a message, etc. Like whatever comes to mind, you can aggregate it and log it and see what happens. Because eventually, when you measure the application, you know what's happening. One of the best tools out there for this is statsd from Etsy. Statsd is a daemon, again, running on a server, and it allows you to send it measurements. It collects them, stores them on a server, and you can grab them later. But here's a sad fact. Logs are lying to you, or at least they will try to. They don't do it on purpose. It's just sometimes you'll encounter a piece of code that looks okay on the surface, and even after analysis it will be okay. But when you deploy it in production, all hell breaks loose, as you're about to see. One application that we developed was using DynamoDB as one of the backends. Yeah, I said multiple backends. Don't worry about it. It doesn't matter for now. So what's DynamoDB? Another crash course. It's Amazon take on document or NoSql database. It is built with speed and scale in mind, and by setting the proper throughput on reads and writes, you're being charged money. The more speed you need, the more money you'll spend. That said, after 2 years of using, I believe it is a prime example of everything that is wrong with NoSql databases. And this is coming from someone who has cursory knowledge of database systems. So back to the story, right? The application in question processes about 4 million items multiple times per day. It is quite normal to have 2 or 3 runs per day, which when you do the math, it means at least 10 million records a day, right? Data is stored in a temporal table. That means that every day a different table is being used to write data. Getting data out of those tables is like a separate world of pain, no concern for these events, as per Amazon's best practices. The logging and metrics follow the ingestion of data. We have good exception handlers in place. Everything looks airtight and good, right? The data is being written in batches in the optimal way to do it, and it's using batch writer to do it as per Amazon best practices. The new deployment is running smooth, as you can imagine, and everything looks perfect. And then a Slack message comes through. Are we writing data to the DynamoDB? And then is when the fun begins. I'm looking at the DynamoDB console, and in the tables, I see that there is data missing. Not a bit of data, a lot of data. Over a course of a week, over 40 million records are lost. And nobody knows where they are. The logs are clean, the metrics are green, just what the hell happened? A number of hours head-scratching and cursing passes, and I know that something is broken, I just can't put my finger on it. I'm running the workers manually to see the output live, no dice. Then I start wondering why there wasn't any exception ever. I like to think that I'm good, but I know that I'm not that good. Which leads me to the documentation, which leads me to the biggest WTF moment so far. So this is a screenshot from official Amazon documentation on the DynamoDB client constructor, right? As you can see, it takes a config array, and there is like a crapload of options for this and that. And unless you are a really, really careful reader, it is easy to miss, because apparently at Amazon, nobody knows how to bold text. There is a key called error somewhere at the end, to which you can pass a callable that will be called in case of error, and then you will get the exception of what happened, right? So let me say this again. What is happening? By default and by design, when an error happens, batch writer will ignore it, drop the payload, and continue on, giving you a false positive, which in turn will cause 4 days of data to be lost, right? If, on the other hand, you register your callable, you will get an exception as argument. Does not tell you much, because by the time you get to the exception, the payload has already been lost, and you're left there twiddling your thumbs and thinking happy, happy thoughts, right? Fine. Now I have our handler in place, and now I can see and what's happening, and now I'm starting to lose my mind. The problem is that 60% of the cases boil down to the following: typecasting. So DynamoDB needs to have its data typed, right? And it only has primitive types like number, text, and such. Ultimately, the payload is JSON, right? And if you do not encase your numeric values, Java will try to infer the type from past value. Then DynamoDB will start screaming and having a pissy fit, resulting in an exception, right? Other 40% of the errors was exception on string values that were basically along the lines that you cannot mix multiple types on a string. At that time, I just never got to the bottom of that. The failure rate was too high. So what we did is basically migrated away from DynamoDB to MySQL. And as the system was distributed onto workers, it was easy to do, because all I did was to stop the workers that were writing to DynamoDB, rewrite the code that was going to use MySQL, start the process, and then the queue would be emptied, and eventually everything would catch up. So again, the system was launched, the performance was there, everything was running smoothly, and then funny things start happening. Again, the system would slow down, and then it would go back to full strength. Completely random, like not a hint of pattern in sight, right? Again, things were chugging along. There's a feeling in my gut that something is not right? Again, logs clean, metrics, the one that we are capturing are good. But I'm deciding to add more metrics and time different parts of the application, so I can actually see what's going on. And suddenly, once graphed, I see that the values are showing a spike. And they showed me that a lot of time is being needed to process the message completely, and I have something to track, right, and measure. I'm adding more timers per segment of the operation, and it turns out that the database writes were slow, and that a lot of time is passed before they are completed. So if you have, let's say, 2,000 workers, right, and each of those workers is writing to database, how do you call this? Can anybody tell me? Really? DDoS. We were basically DDoSing ourselves. I was really, really lovely. So what do you do? I mean, again, you take an axe to it, and you rework the system just a bit, and now they are going to be dedicated workers that are just going to be writing to the database, which in turn allows the processing workers to work at full capacity, because any data that needs to be written to the database is published into a separate queue. So no more waiting time, right? And on the other hand, the database workers now do not need to insert per message, but now we can actually batch it, so that, let's say, 100 messages are written into a database in batch, which is a lot more performant, and you're not overtaxing your database. Oh, sorry. Right. When the transition was done, with this change and few things more that we added, we ended up with a system that could take 200% more now than what we were throwing at it, and we could actually shut down some workers and save money at the end of each month. So after that, like, time passes and other weird stuff starts happening. So one day, one of the systems stops. I mean, we're not talking about, hey, it's not processing. We are talking about things are not running that stop, right? I SSH it into the box. The terminal is abysmally slow. It turns out that there is no more disk space on a drive that has 100+ gigabytes, right? The usual suspects give me nothing, so I decide to look into logs, and lo and behold, there is a log file that is more than 80 gigabytes sitting there, right? There is literally 0 bytes free on the drive. I cannot cat it, I cannot open it, I can't do it and do anything about it. So I just delete that log file and things go back to normal, right? I monitor the system for the next day or two, nothing happens. Nothing causes the log files to feel like that. I move along, almost forgetting that it ever happened. Months pass by, and then again, system stops, right? Same drill. Log in, check the logs. This time, different log file. Again, you can't do anything with it. I deleted it, monitor it, nothing, move along. Again, almost forgot the incident happened, and then it struck again, and then I decided, like, no more. I'm getting to the bottom of this, one way or the other. Again, disk is full, one huge log file, I delete that, the system recovers. But this time I decide to pick up all the archived log files and transfer them to my machine so I can analyze them at my pace, right? I pick one from the worker that created the mess, I unpack it, and I literally break my machine. I had to abort when it grew over 50 gigabytes in size. I pick another one, which looked smaller, like some 100 megabytes of archive. I unpack that thing, and bam, it's a 26 gigabyte text file out of a 100 megabyte archive. So I have evidence that of what might happen, and log of this size is not normal, right? I open that, and 99.99999% of that log is one line repeated over and over, right? Now I can pinpoint the problem. Turns out it is a matter of edge cases. For reasons that are best remained undisclosed, we were using shared memory and semaphores and some arrays, and under certain conditions, the index of array would break out of bounds and is never reset. The log would get nice warning index out of bound message, and by the time we caught it, it was already too late. Again, at that time, no unit tests, no metrics in that segment of the application. Suffice to say, that was changed. 3 lines of cost to fix, couple of grand of revenue lost. For those of you who are still paying attention, the valid question would be, why wasn't there a separate log partition? The answer, 10x. We had a 10x working above us, and this person was incredibly smart and clever and usually made decisions that were correct, but they were kind of short-sighted because he felt that they would change easily as we go along. Unfortunately, many of these things were undocumented, and once the time came for this person to leave, we were left with some gaps in the knowledge, sometimes essential, sometimes if not. In this particular case, we actually had an EBS volume set up for the logs, but it was not set to auto-mount on reboot, right? This was documented exactly nowhere, and nobody noticed until crunch time. So live and learn and document. When you work with distributed systems, client expects that you can scale them up quickly. Unfortunately, sometimes that is not the case, right? In our case, the problem was the technical decision that the files needed to be processed are stored locally. That worked okay for a while, but as more items needed to be processed, the things started bursting at the seams. So we had more than 100 gigabytes of space at our disposal, but when we discovered extra data that can be processed out of the files that we captured, things got out of hands pretty quickly. The workload was so great that you could not use only one instance, but we needed more workers, and we could not do it at that time. The reason why? Local storage of files. Thing is, this is a common mistake. If you start using terms like message, distributed, and similar, you can't use term local for anything anymore, right? It was really a lovely chat with a client where I had to explain why things are slow and what can be done with it, but unfortunately it went rather well. I managed to make the changes so the files are being stored on S3. We deployed it within a week. I decided to make sure that the changes would not break anything, so double check. In the last day or so before deployment, I noticed that time to process the item was again getting slow. The reason is that the data was being downloaded to local drive and then passed to WKHTML to image, which would then generate the image and save it as a file, which would then be uploaded back to S3 for final storage. And in case you didn't pay attention, I was basically trashing the local hard drive, and that was really slow. First investigation showed that little promises WKHTML image did not support streams, but that was true for the version that we were using, and the then recently released one, it was like supported but undocumented, so I had to fiddle around with that and figure it out. And then a few hours later, the deploy happened, and the system will work beautifully, catching up on the workload, and even the memory generation, even with extra memory usage, it was saving quite a bit of taxing on the resources of the system, and turned out that it was twice as fast as we started with, right? And again, different day, different adventure. One fine morning, there is a ticket that says there is a lot of data missing from workers processing the information, right? It's a fairly simple system. Again, collects data from external resources, meaning scrape them, and then you have these workers that are distributed across several instances without rhyme or reason. A part of the processing would just not yield any data at all. So when scraping the data, first thing that comes to mind is like, it's a markup change, so fine. I start downloading the samples across the instances and adding them to our test suite. That takes a couple of hours because they are variants, and then you have to like download them, analyze them, add them, yada yada yada. So now I think I have all the variants and all my tests are still passing, and scraping of the test files still working, but the production is still dropping a lot of data, still no pattern in sight. So fine. Time to do the things the hard way, browser reproduction. So I started to browse and reproducing the steps that are required to get the data. This is time consuming because the pages that we need are not easily accessible, right? And again, a couple of hours pass, but then I can see that things are working out in the browser as they should. As a last-ditch effort, at the step that is failing, I open the Chrome tools and I copy the URL request, I execute it from the terminal, and things work. I do the same from the application, things do not work. Like, what the hell? Okay, let's see what happens when I output the last request data. This is basically a two-line output. First is the request method, the second is the URL. And then I get the first real break. When I do a post, the last request shows a get. What the hell? Remember that this code has not been changed. This should not happen ever, right? Sure, time to bring out the big guns, aka Wireshark. For those of you who don't know, Wireshark is a network protocol analyzer. And then I see it, and then things start to make sense, right? I'm sending an HTTP request to post. Like a post request, right? The site sees it and sends me back a 301 to HTTPS. I didn't see it in the application because the redirection is enabled and the last request will be a get. And then, or the reason why this is happening randomly, because the site we were scraping was starting to roll out HTTPS and some servers were not yet configured to enforce HTTPS. To fix this, I needed to add one S in 2 config files and be on my merry way. 18 hours were spent on this chase and 20 seconds to fix it. Fun stuff, right? It gets weirder, believe me. So, one day, an email comes from Amazon that says that one of the keys that is associated with our account was caught in the wild, and that we should take immediate action, which we took, and turns out that that key was deprecated 6 months before, and that nothing is using it. We send an email back to Amazon informing them of the situation. Amazon says, okay, everybody's happy, everything works, everybody forgets about it. Fast forward 6 months. One morning, 6 a.m., I get up, make me some coffee, sit down in front of my machine and check out my systems data board, and something is wrong. There are way too many counters not present, and those that are sending the information that is way above acceptable thresholds. Okay, so let's see what's going on. I log into the AWS console, and this is where the roller coaster ride begins. The application was leveraging spot instances as they were dirt cheap and disposable for computing power and mass, right? There are no spot instances running. To make matters even more fun, the spot instance requests are also gone. EC2 instances are still present and running, but I can't spin up anything new, and running resources are operational, but I can't add anything to it. This is going to be trouble. I know it. This is going to be a long day. So I'm trying to contact the Amazon support and not getting back any response. Time passes, 3 hours are gone. I got some 3 more hours before morning shift starts to come in, and they need to have at least part of the data ready. I'm making the call. I'm calling the CTO to inform him that we have a problem. Phone rings for a while and sends me to voicemail multiple times. I mean, it is as o'clock in his time zone. Time passes. I try to connect Amazon support again with my phone number, but they don't call me back because my number is not on file, right? Time passes. It is noon my time zone, 6 a.m. Eastern Seaboard time. CTO is up. He sees the missed call. He's online. We are talking, and this is where I realize I just had a masterclass in chaos engineering. So The email that was used for AWS support is not in regular use. He checks it maybe twice a year, right? It took him a while to actually find the password to access that email account. When he actually found it, the support actually tried to contact him, but there was no one to reply. So like, okay, fine. He contacts the AWS support, clears it with them. Another 2 hours pass. We are in hour 8 of the outage. The information is now coming in about what happened. If you remember that key from the beginning of the story that was deprecated, and where Amazon said, okay, was for some reason flagged in a back audit, and AWS decided to protect us by blocking our whole account. And they used the email on file to notify us. Now that everything was clear, the account would be restored in the next hour or so. So I asked about the spot instance requests and all other missing things. No luck, they are gone, as the policy is to shoot first and ask questions later in these cases. Next few hours, and this one is on me for not having this part automated. I spent putting back everything in order. So 16 hours later, we were back in business and operational. So what was the damage? For that day, above $1 million in revenue lost, daily wages for some 300 people who were prevented from working but would get paid anyway. Awesome. And again, on another day, something weird happens. So that back office for the client that I was talking about, it had like 3 people using them. And amongst the other things, it does warehousing and packaging. One fine morning EST, as things are starting to pick up because people are arriving to work, we are getting reports that the website is going down. And I'm noticing a slowdown across the systems and workers as well, right? A team member is starting to look into logs and he's seeing a lot of failed database operations. I'm scrambling into the database, listing the process, and there is quite a few of them that are waiting and quite a few of them that are old, and the new ones are still coming in. And the database server is not a small one. It is R3 4x large at that time, which means it has like 16 CPUs and 120 something gigabytes of RAM. It's not a cheap one. I mean, I'm starting to kill the oldest queries in the database to see that if things improve. There is always a possibility of unoptimized, unbounded query, but as I'm killing the queries, new ones are coming in, and amongst them are the same ones that I just killed. As I'm playing whack-a-moles with queries, the team is trying to determine which part of the system those queries are coming from. The database server is starting to act like Titanic, and we need to do something before it goes completely down. The team identified the queries coming from the warehouse-related code, so we decide to, so actually I make a call to kill the web server and make sure that it times out for 30 seconds. It's a nasty solution, but, you know, desperate times. And so we did. And suddenly things are back to normal, as if nothing happened. People continue working normally, making money. Now, the on-site team has been sent out to inspect the packaging stations to see if anything was wrong, and they come back with the mother of a story. So, the packaging station basically looks like this. There is a conveyor belt coming next to it, and there is a barcode scanner that has a place where it should be put away when it's not used. You have a keyboard which is kind of slanted, and you have a screen here, right? For whatever reason, that barcode scanner was not in place. It was placed above the keyboard. Something happened. Somebody nudged that whole station, and the barcode scanner essentially landed on an F5 key. Yeah, as this is the browser and the application was in full screen mode, this effectively triggered an infinite refresh. The page that was being displayed was using some very, very, very costly queries that were killing our database server and the rest of the system. Yeah, welcome to my world. Yeah, that was fun. And then a month or two passed, right? And after that, in the middle of the day, I get again another message on Slack like, why is the application down? And I go like, no, it's not. And they go like, yes, it is. And I go like, no, it's not, because I'm actually seeing the like the dashboard, and it's working. And if you continue, if you check with me, I share the screen, like, things are working on our end. Like, figure it out. It's yours. They sent a team out to see what's going on. fairly quickly, the team comes back to us, and I get another message that it's actually not us. So I say, like, sure, okay, fine, I knew that, but I want to know who it is. Turns out it is the city. So this company is in a small city in America, and they were hiring a lot of people, and the city wanted to do something nice for them, right? So what can you do for people in America? You can actually make a parking, right? As a surprise. So they brought the excavator, and like the first dig with the shovel of the excavator, they pull out the fiber optic cable and kill the whole system and kill the whole process. Rest of the day, one person was actually crawling to the vents, setting up, and the air ducts, setting up the wireless backups and mobile hotspots. That was just beautiful. So, if you're working with distributed systems, dumpster fire is your normal daily routine. And unless you feel really, really comfortable with some, in retrospect, questionable decisions, you're not going to survive long in this job. So with that, thank you. Any questions? Oh, I have 2 shirts from PHP Serbia for the first 2 questions, right? Anybody? Ooh. I'm so happy that nobody has anything to ask. Right? Okay.
Any questions, guys?
You can ask him in Russian. He will translate. So.
Yeah.
Thank you. So how do you mitigate the excavator?
Oh, I have no idea. They fixed it on their own. It was not my problem. As long as they had an audit trail, it's not us.
But
your problem.
Okay, better question is, how do you detect such failures faster? And what have you done after that story to
You
be
can't.
able to...
I mean, this is what goes in insurance as an act of God. Like, basically, like, these guys went out from their offices and they saw the excavator with a fiber optic hanging out there in the shop. Like, what the hell can you say? How do you defend against that? The only thing that you can do is actually set up a secondary network, which was done after that, because nobody actually anticipated this thing is possible.
Mm-hmm.
Right?
Thanks.